This is Mike Schlesinger from NetApp, and in the next few minutes I would like to show you how VMware Site Recovery Manager and the SnapMirror replication technology and cloning capabilities of NetApp and IBM N-Series storage arrays can be used to provide a robust and easy-to-manage disaster recovery solution for your virtualization environment. Before we talk about the storage array, we should quickly review Site Recovery Manager. SRM is a VMware product that provides DR workflow automation. By integrating disaster recovery into Virtual Center and making DR protection a property of the virtual machine, SRM allows an administrator to pre-program the response to a disaster recovery event. SRM works as a Virtual Center plugin. Virtual machines are collected into protection groups at the primary site. These groups can then be recovered by executing a previously prepared recovery plan at the DR site. SRM directly addresses recovery time objective issues. It significantly increases the speed at which an administrative team can recover an environment in the event of a disaster. However, SRM does not replicate data. It is dependent upon the replication technology of the underlying storage arrays. Core NetApp technologies like SnapMirror and FlexClone provide unique capabilities for a SRM environment. NetApp Storage provides the simplest snapshot model in the storage industry. Since NetApp snapshots do not copy on write, nor do they use a dedicated copy-out region, they provide the best disk utilization and performance, especially when keeping multiple snapshots. NetApp FlexClone technology enables SRM's DR testing capability by providing instant, zero-cost copies of VMware data stores with no need to pre-provision containers or physical storage prior to executing the test. SnapMirror efficiently replicates data between sites by leveraging NetApp snapshot technology and replicating only the 4K blocks that change between SnapMirror updates. SnapMirror is also reversible for the purposes of DR failback. In the event that the primary storage is not completely lost in a disaster, only the new data written at the DR site need be replicated back. Additionally, when SnapMirror is combined with NetApp deduplication on primary storage, only unique data is ever replicated to the DR site. Traditionally, testing a DR process has been lengthy, complex, and prone to human error. Due to physical environment limitations and the difficulty of performing DR testing, most environments are only able to do so a few times a year. In fact, some environments are completely unable to execute an actual DR test. When an SRM recovery plan is tested, NetApp FlexClone copies are instantly created to present the data stores to the ESX servers. There are no pre-allocated containers or physical disks set aside for this purpose. FlexClones share common data blocks with their parent volumes but behave independently. They are created as SRM needs them and removed when the testing is complete. FlexClones require only a small percentage of additional capacity for any new data written into the volume during testing. Because the test is running on FlexClone copies instead of the original volumes, testing can be performed without interrupting the SnapMirror replication process. When testing is completed, the FlexClones are removed. NetApp FlexClone technology makes SRM DR testing so simple that the DR testing environment can be created at any time to test the functionality of the DR plan or the impact of changes to the production environment, such as applying patches or hotfixes to your virtual machines. Let's take a look at an SRM DR test in action when using NetApp storage. Here we are connected to the Virtual Center server at the DR site. In the SRM plugin, we have created a recovery plan for a couple Windows virtual machines. We start the DR test and SRM begins by preparing the storage at the DR site. There are many steps required to reconfigure the DR site during a test or a failover. SRM dramatically simplifies this process by automating these tasks into one easy step. Taking a look at the console of the storage array, we can watch as SRM communicates with the array and performs the necessary tasks. SRM creates a FlexClone of all the required data stores, configures all the LUNs to make them accessible, then performs a storage rescan on each of the ESX hosts to connect the storage. Once the storage setup is complete, SRM proceeds by registering and starting each of the virtual machines according to the recovery plan. SRM has finished starting the virtual machines and Virtual Center shows that they are running. The administrator may now perform any necessary DR test validation. After starting the virtual machines, SRM pauses the DR test. Once the DR test has been verified, we can return to the SRM plugin and click Continue to finish the DR test. Let's return to the console and watch as SRM cleans up the temporary storage. The clone of the data store is taken offline and destroyed, and another storage rescan is performed to remove the data store from the ESX configuration. The DR test is now complete and all of the temporary storage that had been created for the testing has been removed. In the event of a real disaster, FlexClone technology is not used. Instead, when a disaster occurs and the SRM recovery plan is executed, SnapMirror replication is stopped and the volumes at the DR site are made writable. The virtual machines are activated using the configuration files and virtual disks that were replicated from the primary site. If you would like more information, NetApp has provided a detailed description of an implementation of SRM in a NetApp environment. Please see Technical Report 3671 at the NetApp Technical Library.